Hello at home, students. We have been doing some review lessons from everything you guys learned in developmental math. That was the first 3 lessons we looked at. Today we are starting looking at some new material, specifically something on ratios. So that objective is going to say I can write ratios and find equivalent ratios. In that sentence, I would say there's 2 math words we're going to be learning today, ratio, and then this idea of equivalent ratios. Now you've seen the word equivalent before. Do you remember what equivalent means? Equal? Mm-hmm. Yep, Francis is saying equal. It's like the fancy math way of saying equal. We saw the word equivalent when we were talking about fractions. Equivalent fractions were fractions that equal the same amount. Equivalent ratios are going to be real similar. Ratios, you actually see fractions a lot with ratios. And then that word ratio, right? Does anyone know what a ratio is? That is quite all right, because that's where we're going to start, is our definition of a ratio. When you talk about a ratio is a comparison of 2 numbers, 2 amounts, 2 quantities. You can think about it any of those ways. So to help us introduce what a ratio is, I've got this question right here about Denise. It says, Denise is making a punch for a party. The recipe calls for 3 times as much fruit juice as Sprite. And the first question is asking us, let's write a ratio. Write a ratio of fruit juice to Sprite. Now we just said a moment ago, a ratio is what?
2 numbers.
Yeah, 2 numbers. So when I go to write my ratio, I need 2 amounts. I need the amount of fruit juice and I need the amount of Sprite. In the recipe, it says the recipe calls for 3 times as much fruit juice as Sprite. What would those 2 numbers be?
3 times as much as fruit juice as Sprite.
Mm-hmm. But I need 2 numbers. So the 3 is for how much?
6, right? No. Wait, 3 and 1?
Yeah. When you say 3 times as much fruit juice as Sprite, it means if I put in 3 cups of fruit juice, I want to put in 1 cup of Sprite. When you go to write your ratios, there's a couple different ways you can write it. When you're writing a ratio, we don't use the words in it. We're just using those numbers. So one way I can write it is 3 to 1. When I write that, that's telling me 3 cups of fruit juice to 1 cup of Sprite. I'm using cups as my measurement, but it could be like 3 bottles of fruit juice to 1 bottle of Sprite. It could be 3 ounces of fruit juice to 1 ounce of Sprite, whatever you're measuring with. So this is option number 1. Option number 2 is using this colon here. You read this the same way you read this. If I see this, I would say 3, 2, 1. And then the last way is with a fraction. You can say 3, 2, 1 like that. Now with this fraction, we learned earlier this week that this equals something. What does this equal? I didn't hear you, I'm sorry. It didn't come out. I'm sorry, I didn't hear you. What did you say? 3. Why would I want to write it like this and not just put down 3?
It's like 3 wholes, right?
Mm-hmm. We're asking for a ratio, and you told me I'm going to go, what is a ratio?
2 numbers.
2 numbers. So for this, because I'm writing it as a ratio, I want to keep it as 2 numbers. I wouldn't say that equals 3. Are we okay with this first part here? All right. So the second part is saying, let's create a table of the possible amounts of fruit juice and Sprite that Denise could add to make a punch. So one option is the option we already said. She could add 3 cups of fruit juice.
And 1 cup of Sprite.
Yep. That would give her how many cups of?
4.
Yep. Now if Denise is having a party, I imagine 4 cups is probably not enough liquid. So what's another option she could do?
Chicken with 6, right?
6
With 2.
with 2.
That's going to be 8.
Yep. Maybe Denise is having like a real big party. That's still not enough. What's another option?
Well, you can do 9.
And I'm going to have someone from this table here tell me 3, which would give us 12. I'm going to pause right here. Tell me how you guys are getting these.
Because the cup is with 1 Sprite. If
Mhm.
you choose, you got it with 3 times, like 3, 6, 9.
Mhm. So I'm hearing you go, you're counting up like 3, 6, 9. If we wanted to keep going with that, this would be.
Can you skip like 3, 6, 12, or no, not like that? Like,
So-
like let's just say 3, 6, 12, then instead of saying 9, then just put 3.
Sure. So if instead of this row here,
Yeah.
I'm going to erase it. If I wanted to just say, what about 12?
Yeah.
4.
Yeah.
4. Where's that 4 coming from then?
Because
It would be the cups of Sprite, and then
you divide it by 3 to get 4.
ooh. So you're saying I notice if I divide this number by 3, it gives me 1. So I could say 12 divided by 3 gives me 4. I'm going to finish up this row real quick. That gives us 16. So I'm going to pause here and just summarize some of the stuff I've heard. I heard you were saying we can count up. So we could go 3, 6, 9, 12, and keep going with that pattern. What type of math is that when you're counting up by something? Addition. So one way we can keep creating this table is by using addition. Let's say Denise is doing this for like a wedding and we need a ton. I don't want to keep counting up. I don't want to keep going like 3, 6, 9, 12. Let's say I know she needs a ton. So she's going to get 300 cups of fruit juice. How many cups of Sprite would we need then?
For me, at least like 250.
Focus in on this original ratio. We've got 3 cups of fruit juice to 1 cup of Sprite. Francis, I hear you saying 100. Where did that 100 come from?
Because in 3 cups, you only needed 1, so 300 cups, you need 100 cups of Sprite.
What type of math are we doing there?
That is,
It depends which way you're going, right? If I'm going from this to this, then we got division because we're going smaller. If I'm going this way, so I'm starting with that original ratio, and then I'm making it bigger, what type of math is that? Multiplication. 3 times, not 6. 3 times what gives you 300? 3 times 100, and then over here, 1 times, not one times, 1 times
100.
100. Same thing. So there's a lot of different ways you can get these ratios. If you're keeping it smaller, right, we can just use addition. We can count up 3 plus 3 gives me 6. 1 plus 1 gives me 2. 6 plus 3 gives, whoops, no, never mind, that's not what we did. But originally we had 9 and 3. You can keep adding. That's one way to find ratios. Or if you're really trying to use that ratio to make a large quantity, we could use multiplication. Now you guys are like a step ahead. I already heard you saying if we want to go smaller with that ratio, then it would be division. Let's finish up this row. We've got 300, 100, and 400. No matter which of these she makes, for each of these recipes, these combinations, what is true? We could say, go back to that original one. We could say for every, how much fruit punch?
3 cups of fruit punch,
Yep.
there is 1 cup of Sprite.
Yep. One way she could make that 300, 100 combination is she could say for every 3 cups of fruit punch, 1 cup of Sprite. 3 cups of fruit punch, 1 cup of Sprite. She could do that 100 times and she would end up getting 400 total cups. How are we feeling about ratios, writing all these different ratios? Okay? All right. The next part asks for you to talk with a partner. There are 3 of you. So that doesn't work out real great. But what we can do instead is I'm just going to put the question up. Pretend like I'm not here. I'm going to give you, just the three of you, an opportunity to talk through this. So talk to each other, pretend I'm not here in the back. The question is a ratio of 3 to 1 the same as a ratio of 1 to 3? We're not going to write anything on our paper yet. You're just talking to each other.
It's the same, it just flipped.
Talk to them.
Oh, it's flipped, right? Let's say this, it's like a cup, like juice cup. If you can switch it to 1, like let's say fruit punch is 1, and Sprite is 3, it's gonna be the same number. Yeah. So let's say this, one cup of fruit punch, well, 3 cups of Sprite or 4, and then it keeps going. So two cups of fruit punch with 6 cups of Sprite will be 8.
Yep.
Right. That's what I think.
What do you all think?
Yeah.
I agree.
We agree? So we're saying, yes, they're the same. And the reasoning I heard, we were going back to fruit punch. So we were saying, for this one here, you're saying this ratio is the same as 3. I'm just going to write punch instead of fruit punch. 3 punch to 1
Right.
Sprite. And then this one here is,
There's like 3 punches, 3 fruit punch.
It's one.
Nope.
I mean, 1 fruit punch.
I always got it. That's 1 punch to 3 Sprite. And you were saying those give you the same amount. I heard you saying the same amount of punch.
Let's say like 2 fruit punches and 6 Sprites. They're gonna be equal to.
So we could also make more of these.
Yeah, but
I'm asking, are these two things the same?
they just flipped.
They're just flipped. Did I hear a no over here? We were saying yes before.
You're not getting the same amount of punch as you were the first time or Sprite.
So we're thinking over here, we're not using the same amount of our ingredients.
Right.
So you were pointing out you would end up with the same total amount of
Yeah,
liquid,
that's what I'm saying.
right? Here if we were using cups, this would be 4 cups.
Yeah, that's like different, like taste of it. I'm talking
Oh,
about
okay.
numbers. That's why. It's like it's like flipped. That's it.
So they're similar in the sense that you would have the same total amount, but you're going now to taste and like the amount of ingredients. Would these two things give you the same punch? Not the same amount of punch, but the same punch.
No, it would be tasting different.
It would taste
It
different.
tastes like more than like watering from my opinion.
So let's go back to the question. Are these ratios the same?
No.
No. It would give you the same amount, but when you switch around the numbers in your ratio, we got to it. It's going to talk about different amounts of those ingredients. And you're pointing out it would be like a different punch. It would taste different. One, it sounds like would taste better than the other. For that why or why not, what could we say?
It would taste funny.
I'm just going to, we're not going to judge the punch. We're just going to say they will taste different. If I pushed you to keep going, they would taste different because?
Amounts are different.
Ooh, yeah, because the amounts, the amounts of the ingredients are different. Think back if you've ever followed a recipe, you can't just like switch around. If it says you need, I don't know, 5 cups of flour and 1 cup of sugar, if you flip those things, that would be tasting funny. So what I want to emphasize from this question is when you're talking about ratios, the order those numbers are in is really important. We can't switch around the numbers because it's switching around the amounts of ingredients. So the last part of this first section is practicing writing some ratios using you all in the room. We're going to write these following 2 ratios. The first one is, what is the ratio of students who have a sibling to students who are an only child. You're gonna have to talk to each other to figure this out.
Like how many total like siblings that I got? Like, what you mean by that?
We want the ratio, I'm gonna box some stuff out. We want the ratio of students who have a sibling
Uh-huh.
to students who are
Only child.
only child.
Only child is one.
I have 5 siblings, so
So which category are you in?
students who have siblings.
Students who have siblings?
Me too. I got 6. Well, no, I meant 5. So me included 6.
You included their 6.
Yeah, I got 2 siblings.
So where are you? Okay.
3 to 0.
It would be 3, 2, 0. I'm writing it exactly how you said it. I heard you say 3, 2, 0. How else could we write that?
3 dots. Those
Mhm.
dots.
Colon.
And then
3.
3 over 0.
Yeah. All our different options. The second one, what is the ratio of students who were born in Indianapolis to students born outside Indianapolis?
I was born in Kentucky.
I'm born here in Indianapolis.
Outside?
Yeah.
Uh-huh. So what's that one going to be?
So it's gonna be 1 to 2.
1, 2, 2.
2 to 1.
So great question. I hear 1 to 2. I hear 2 to 1. Can we write both?
Wait, does it
Because
matter?
the writing ratio of students.
Or is it just like, is it like the beginning of the
okay,
sentence,
okay.
like it's
1
asking
to
for
2.
Indianapolis after that, then outside
Yeah.
Indianapolis?
So Carlos is going back to the sentence. It's saying Indianapolis first, 2 outside Indianapolis second. So which one do I need? 1 to 2. Nice. If I wrote 2 to 1, what would that one mean?
It's like two students was born in Indianapolis,
Mhm.
and just 1.
Yep. If I switch it around, it means the opposite of what you guys told me. And then again, we could write it with our colon or as a fraction. How are we feeling about writing ratios? The last part is going to ask you to write a ratio. Before you go on to that, I just want to point out one more time. Notice the way the question is written. We've got something to something else. So make sure you're using that structure when you write your question. You want to write a ratio by putting something that could have a number amount to something that could have a number amount. Does that make sense? Okay. We can try. The last part. Write your own ratio relationship and represent it with a ratio. Put down a question that you could ask your classmates. So what is the ratio of students, ... Take about 1 minute.
Write our sentence.
Yeah. Take about 1.5 minutes. You saw the questions I asked. I asked about siblings.
I just asked for that, like the mask thing.
What about masks?
Like who has it on?
Remember the structure we had, though.
Yeah, I
So
said,
who-
what is the ratio of the students who have the mask on, I guess?
But who have the mask on to something else.
Oh, okay.
So what would be the second part? Ratio of students who have masks on to...
So the students don't.
Yep, that would work. All right. Let's hear some. Carlos, I already heard yours, so I'm going to have you say it first.
I said, what is the ratio of students who have the mask on to the students who don't got on?
Yeah. So we've got what is the ratio of students who are wearing a mask to students who are not wearing a mask? For you all, what's that ratio?
3-0.
Yeah, 3-0, because we're all being responsible. Perfect. Francis, Io, you got one?
What is the ratio of students who have a car to students who have a skateboard?
Car to skateboard? Okay, so we've got what is the ratio of students in this room who have a car to students who have a skateboard?
I like both of them.
You have a car?
I do too, but I got a skateboard too.
Fun. So we got car.
Well, I don't know. I have both of them.
I'm going to put you here.
Huh?
Okay. We got 2-1. That's a good thing that came up though, is usually they're like opposites like yours, like masks. I was like, what did you say? People wearing masks to people not wearing masks. These aren't necessarily like opposites. So we could ask separate questions. We could ask people who have a car to people who don't have a car. Did we all say we had a car?
Yeah, I do too, but I like skateboard.
So we could do
Skateboard is fun.
maybe people who prefer cars to people who prefer skateboards. I'm erasing this, but Francis,
Well,
what's
that's
yours?
Fun, but far
Mine
better.
was find out the ratio of the kids that eat peanuts to kids that cannot eat peanuts.
I like that.
Can everyone here eat peanuts?
I can.
Peanuts. To people who can't eat peanuts, we got Yay, no one's allergic. Okay. I think you guys have got it. One of the things we want you to leave this lesson with is being able to look at something and say, that's a ratio. So if you're able to write something like that, it means if I say, like, write the ratio of students who are wearing masks to students not wearing masks, you'll see that language and know, yes, ratio. I also liked hearing all your ratios. The second part of this is going to get into equivalent ratios. And at the beginning of this lesson, you told me equivalent means
Equal.
Yep. So right away, we've got an idea. It's talking about equal ratios. I've got another food example. But in this one, we've got Kimmy loves ice cream. She notices the Kroger ad below. Use the information in the ad to fill in the table. So in this ad here, I see a ratio. What is the ratio? 2 to 5. What are those numbers referring to? The 2
It's
is?
the ice cream.
So
And the 5 is just the dollars, how much you gotta pay.
yeah. So one ratio we could get from this is we could say, if you buy
You got the 2
2 tubs of ice cream,
costs $5.
it costs $5. Now they've got it written, notice it's written as a fraction. You see that slash there? Let's write ours using a colon. So our ratio could look like,
2, 5.
yeah. So that's one option. What is another ratio we can get from that information?
4, 10.
How are you getting the 4 and 10?
Just 2 more. Wait, 2 more. So another 2 is gonna be 4. Plus 5 plus another 5 would be $10.
Yeah. So I hear you're saying I'm doubling it. I'm doubling how many? Doubling the cost. 4 to 10 would be our ratio there.
I got a good question. Is that a deal? What y'all think? For y'all opinion? Is that a
Oh.
good deal or no?
I don't think it's a good deal.
At the Walmart, you get like $1.98 for a tub.
Oh, see?
I like how you're talking about deals though. So if it's $2 to $5, what's that mean about the ice cream?
That's like $2.50 each.
How'd you do that?
Huh?
What math are you doing to figure that out?
I forgot what it's called.
Help him out. How could he figure out that?
Well, I did $5 with the .00,
Mm-hmm.
right? And divided by 2.
Yeah, so you're using division.
Division, yeah.
So if we buy 2 tubs of ice cream for $5, that really means each of them are $2.50, $2.50. What about if we buy 4 tubs for $10?
Still the same price.
Still the same price. What's another ratio we could write?
6, 15.
6, 15. So 6 to 15. What's true about that one? If you buy 6 tubs for $15,
Just 2 more.
you're getting 2 more.
Yeah.
Go back to what you were telling me about the price.
Oh, no, I thought, what is it?
If you buy 6 tubs for $15,
I forgot already. I lost it.
so you said if they're 2 for $5, that means each tub is $2.50.
Yeah.
Francis told me if you were buying 4 for $10,
Yeah,
you said
so
that's still the same price, still $2.50. If I buy 6 for $15,
Another the same, $2.50.
remember what we're talking about here, equivalent ratios. I could keep going. You guys already figured it out. But what's going to be true about all of these ratios I'm writing?
They're all equal,
What's equal?
the price.
Yeah, the price of the ice cream. So when we're talking about all these different ratios, in the first question we looked at too with the table, you can create more ratios. Each of these, each time you're saying, I'm going to buy even more ice cream, I'm buying even more ice cream. But at the end of the day, those ratios are all describing the same thing. They're all describing ice cream that costs $2.50 each. Stores can use this sometimes to make it sound like a good deal. The one I see all the time at Kroger is when you go to the yogurt section, they always say 10 for $10. What's that the same thing as? Yeah, $1 each. But for some reason I see this. I think that's like part of marketing is like figuring out like what numbers people want to see to think, that's a good deal. But they're writing that instead of just saying they're $1 each. But at the end of the day, that yogurt's the same price, right? So I think you guys have already talked about this part here. It says, look at the ratios you wrote in that last column. What do all of these ratios have in common?
No, fair amount.
You said they, what is the same amount?
The ice cream.
Yep, so we could say the ice cream, I'm gonna say, what are we talking about? The ice cream tubs all equal the same amount. So when we talked about fractions, one of the things with the equivalent fractions we emphasized is in your review questions at the beginning, you said 1/2 equals 3/6. And in that lesson back in developmental math, we had said when you're talking about equivalent fractions, the numbers can get bigger, but the amount is the same. I had you guys draw a picture showing that these are the same amount. That same idea with ratios. You can make the numbers in the ratios larger. It just means you're getting a lot of ice cream. But at the end of the day, the amount, the cost of that ice cream is the same, similar to what we had said with fractions. The last part of this lesson, oh, wait, just kidding. Before we do that last part, you were already using the vocabulary with equivalent. You told me it was equal, but there's a spot for us to write this down. Equivalent ratios are 2 or more ratios that are
Equal.
yeah. And by equal, it goes back, you can think about like that ice cream, they're all describing the same cost or the same, with like the fruit punch, the same fruit punch, right? It wouldn't taste different. So given that ratio 2 to 5 in that last problem, how could you find other equivalent fractions? At the beginning, you had said you were doubling it. So you were making it twice as many. If I was buying ice cream for the school and I wanted to buy a ton of ice cream, maybe I wanted to buy 100 tubs, what type of math could we use there? But I'm starting here. Multiplication. This one would be times
50?
So then over here,
What times?
times 50.
100. No, man.
5 times 50?
500.
That's 250, right?
5 times 100 would be 500. 5 times 50 is 250. When you're multiplying numbers like that have zeros on the ends, well, you tell me, how did you do it in your head?
I'm really good at it.
But let us into your brain. How did you do it?
So I did 50 times 5, so I just think that was a piece of paper. I just like So I'd be like, okay, 50 times 5 would be 5 times 0 would be 0, and 5 times 5 would be 25.
I'm going to reverse that. If you're trying to do this in your head without paper,
Yeah.
you can say, well, 5 times 5,
It's 25.
25?
Would be 250.
yeah, and then just put the 0 at the end. That's what I'm doing in my head. So I want to emphasize, if we're keeping it smaller like that, you can use addition. If we're trying to get larger ratios, you can use multiplication. Could we also use multiplication here? Yeah, what would we be multiplying there?
8. Wait, 2 times 4 would be 8, right?
I'm not doing 2 times 4 though.
Oh, I meant divide. So
I'm thinking 2,
times 2 equals 4.
there you go. 2 times 2 equals 4.
Times 2 is 10.
Yeah, so multiplication would work for everything. I probably wouldn't use addition though to get to these larger numbers. Now we're, oopsies, I'm stepping on wires. Now we're on to this last one. It says with a partner, but we are 3 people. So we can talk it through all together. In this problem, we've got Josie took a long multiple choice end of year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. I want to pause right there. So what does that ratio 2 to 9 mean?
2 right and 9 incorrect.
Close. If there was a total of 11 questions, she got 2 correct.
Right.
And whoa, wait, no. She got 2.
Right.
Read through the sentence again. The ratio.
Got 2 incorrect and 9 right.
There you go. So if there's a total of 11 questions, that means she got 2 incorrect, 9 correct. But he said it's really long. So we're going to change that just a little bit. It's not 2 incorrect, 9 correct. I'm going to change the wording just a little bit. You guys know?
Wait, what did you say one more time?
I'm going to skip back actually. At that very beginning with the fruit punch, you see that little quote box over to the side? How did we word it earlier?
For every 3 cups of punch,
Mm-hmm.
there is 1 cup of Sprite.
For every 3 cups of punch, there's 1 cup of Sprite. I'm going to use that for every there is language back here. So that 2 to 9 means for every 2 what?
Incorrect.
For every 2 incorrect questions, there is,
9 right.
yep. So that way it's not just saying there's a total of 11 questions. She got 2 wrong, 9 right. We're saying for every 2 she got wrong, she got 9 right. So the question, part A, says if Josie missed 8 questions, how many did she get correct? How could we figure out that one?
So you said 2, what? 9, right?
Mm-hmm.
So the missing question would be 8 point something.
Ooh, I like how you're saying that. I can see your paper. So he's written, we said earlier 2 to 9. So we said 2 wrong. For every 2 wrong, she's got 9 right. So you went ahead and you filled in. We've got she missed 8. I heard you say the missing number is how many she got correct.
Yeah.
I like setting it up like this. How is that helpful?
Not to get confused with the incorrect, I guess. For my opinion, because I got kind of lost. I was thinking too hard.
Use what we were doing earlier. If I want to find more ratios, what could we do?
Multiplication.
If I'm going this way, I could divide, but we're trying to make those numbers larger, so I'm going to multiply. I'm going to multiply by what?
So 2 times 4 will equal 8.
Mm-hmm.
So 9 times 4 will equal 36.
Mm-hmm. So if Josie missed 8 questions, how many did she get correct?
36.
Yep. I'm going to say 36. Correct. Explain how you got your answer. Let's put this little math work I did into some words. What did we have to do to get our answer?
9
Mm-hmm.
by 4.
Yep. We can say we multiplied we multiplied the ratio 2 to 9 by 4. You know, I'm always asking you guys why. Why did we use 4? Why did we multiply by 4 and not 5 or 100? Where'd that 4 come from? Who told me the 4?
What?
Who told me to multiply by 4?
Me. 2 times 4. 2 times 4 would go 8.
Yeah. So that 4 came from, we saw that was the number we had to multiply 2 by to get the 8.
Yeah.
And then we just did the same thing here. I think part B is similar. We've got if Josie missed 20 questions, how many did she get correct? You kind of led us on this first one here, Carlos. Someone from my other table. We've got if Josie missed 20 questions.
You multiply, 20 by 2.
Multiply 20 by 2. Yep. Multiply 20 by 2.
No, 2 times 20.
2 times
Yeah, 2 times 10.
Where's the 10 coming from?
We divide 20 by 2.
Mm-hmm.
10.
Oh, I bet you that's why you keep telling me division is because you're dividing to figure out what we need to multiply by. Nice. So if you don't know what that number is, I'm hearing you say we'll divide 20 by 2 to get 10, and then we can see 2 times 10 gives us 20. How does that help us out?
So 9 times 10.
Did I hear you whispering it over there?
90.
Yep. How many did she get correct?
90 questions.
Yep. And again, if I asked you to explain, it's going to be real similar to what you did in part A. So at this point, we've done some math. Part C is asking what ratios can we say are equivalent to the ratio 2 to 9? Hmm? Yeah, we figured out for that first part the ratio 8 to 36 was equivalent. Yeah. Are these the only ratios that are equivalent?
No.
No. We saw earlier from that table we could keep going on forever and ever. But just at this point, these are some of the ratios we already figured out. We don't need to do any more math to figure out more. Except until we get to part D where it asks, come up with another possible ratio. I'm going to give you guys 20 seconds. Come up with another possible ratio and then let's hear them. Because you told me earlier there's lots of correct answers for this.
Wait, like a question or just like write a question? Oh.
So come up with another possible ratio for the number of questions she got incorrect to the number of questions she got correct.
Like something like those, like 2, 9.
Mhm. Yeah, don't steal one of the ones we already did. Come up with a new different one. Mm. That would work. Uh-huh. All right, let me hear them. Despite the fact that there are tons of correct answers, 2 of you wrote down the same thing. What's one ratio we've got?
2, 9.
2 to 9 was the original one. So you've got
40
mhm.
will equal 180.
Not will equal, but 40.
2 to 180.
Yep, 40 to 180. If she missed 40 questions, she got 180 correct. How did you get this ratio? What math did you do?
So 9?
You used 2 to 9, and then what math did you do to get here?
The equation thing? Equal?
What math did you do?
Oh, multiplication.
Yep.
Yeah,
Multiplied by
20.
20 to get these. And then you were saying 1, 2.
Yeah, multiply by 6.
Mm-hmm.
Right, 12. Ratio 54.
12. Francis, help us out again. 12 to 54. And you already told me you multiplied by 6. I was laughing because I saw you had 40 down too. What all of these have in common, it goes back to what you said at the beginning. For every 2 she missed, she got 9 correct. So if this was her test, picture me marking 2 wrong, 9 correct, 2 wrong, 9 correct, until I had graded all of those. Same for every single ratio we wrote. How are we feeling about ratios? Good? We like them? Maybe not yet, but we're getting to. But you're nodding, yes, that's good. The last part of this is this one here. I'm going to have you try this one on your own, and we'll come around and check. And then that'll probably be maybe close to the end. Goodbye, people at home.